Okay, in this video, I'm going to show you what happens if we start playing around with the power. What happens to the formula or the values that go into the independent t-test, so you can sort of see that our power increases. So remember, and this is artificial, this is just for demonstration purposes. You would never do this in the real world, right? Because remember, your data is as you collect them, so you can't change this. But what happens if we have greater between group variance? So the way we can do this in our example is I took the original data in our example that we just did in the previous video, and all I did was add 30 to each score. So if I'm adding a constant to each score, the within group variability, or the standard deviation, standard error, the mean of that group, however you want to look at it, is going to be identical. It's not going to change. But what will change is the mean value will go up. So I've highlighted that this value is greater, and you can see that our mean value is now 110, where before it was like 80. So it's gone up quite a bit. So all we did was increase the between group variability. This is remember back to our power lecture, this is one way to increase the power. If we used a stronger independent variable and it produced that kind of effect, this is what would happen. So what I've done is I've also, you do 550 squared, so this number is going to change. And of course you square everything and sum it up, so this number would change. But I did not change anything in the second group, so all of those numbers are untouched. What we then do is substitute all of these values into the formula. So in this step down here, I've just substituted into the formula. Hopefully you can follow that. If not, go back and watch that previous video to learn how to do that. And then we're going to reduce. So we're going to divide our fractions out, reduce this down in our various steps. And when we do this, you're going to see that we end up with a t now of 3.09. And remember, before our t was like less than 1. So if we still use our critical t, now we're rejecting the null hypothesis. We have more statistical power. We have a greater t ratio. And in fact, go back and look, the denominator stays the same. What increases is our between group variability, or the numerator, to increase the power. So we can do the same thing, though, can also increase power if our within group variance gets smaller. So let's suppose that what we're going to do is we're going to tighten our experimental control, and so we have a smaller within group variability. So now the mean value is the same, right, 80 and 78, but what I've done is I've made these numbers much closer together, and you can compare this to the original example, much closer together, so that the within group variability is smaller. Okay, so what's key here, what's really changing, is this number over here, which goes into our standard deviation or standard error, the mean calculation. So with sum of x is still the same because we have still the same number of observations here, same over here. So all of this is the same. This number is going to change though, so we just squared each of these, substitute into the formula, and now what you're going to see is our numerator is the same as it was in the original example, but our denominator is much smaller. Before it was like 10 something. Oops, before it was 10 something. Now it's just 0.6. So our t ratio is much larger. And again, we're rejecting the null hypothesis. So hopefully you can see now those concepts that we learned by increasing power actually play out in the t-test formula itself, how the t ratio grows. Remember, it's the good variance, the between group variance over the within group variance. Now the ratio grows when we sort of artificially manipulate those factors using the independent t-test.